question or comment? So if you go to a fancy restaurant nowadays, $8 is about the cost of a hamburger. If you go to like Pine Street, where they have kind of like, obviously it's not McDonald's, they have like organic stuff. It's about $8 for the basic hamburger. It's like $12 if you want to get all the good stuff, like the fancy hamburger. So hamburgers are pretty expensive unless you go to a fast food chain. Then they're maybe $5, maybe cheaper depending on what you get. Yeah. What? Gold? I didn't say gold. It's like, well, maybe if you treat like that stuff like gold. You guys haven't been to Pine Street? So, or maybe you just don't know how much your parents pay for Pine Street. Pine Street is very expensive. Yeah. It's a little bit cheaper, I think, like barely, but yeah, burgers and cream is good. Yeah. All right, I'm gonna pause this because I'm off track. You're off track. Let's head back. 3, 2, 1. Jameson. Pause. We're going to add and subtract, but this time, instead of just using whole numbers, we are going to use rational numbers. You have to deal with decimals or with fractions. What is an equation? Think about it for 10 seconds. Last week we looked at the difference between an expression. What's the main difference? Compare those two and give me a definition for an equation. Jot down your own definition now. What would you say an equation is? There's not one right answer. A lot of sentences could be correct. What is an equation? Yeah, I'm gonna pause that convo. I shouldn't have answered the question. Turn it back to your partner. Odds, you're going first. If you don't have a partner, look behind you and listen in. What's an equation? Go. Right, and you're an odd. I would add the variables to that right now. Everything else is good. 3, 2, 1. Jameson, what is an equation?
It's a problem with an equal sign.
I'm going to add something to that. That's a great start. What is usually included with an equation if you're asked to solve? Daniel. The equal sign, what else? Chad. What else? Max. What else? Hadley. When you're asked to solve an equation, you will always have a variable. When you're asked to solve it, you're going to isolate the variable, which means to get by itself. You want the variable to be by itself on one side. Those are the two key things we're working with Friday. And here's our steps that we learned. You're going to, number one, every time you have an equation, I told you Friday, I don't care about the answer. And the same thing about today, I'm more worried about your setup. So step one, you need to draw a line to split the equation into two sides. You're drawing a line down the equal sign to show you where you're isolating the variable. Then you identify the operation. What's happening to the number next to the variable? If it's adding, you're doing the inverse, so you're subtracting that number. You apply the inverse operation. It's kind of like balancing a scale. If I add, I have to subtract to both sides. If I subtract the number, I add to both sides. Then you're solving, and I'm going to show you a cool way to check your work and be very confident when you finish a problem like this on your test. Okay, so Let's head to example 1. It says to use inverse operations to solve a one-step equation. First step is to draw a line. Go ahead and do it. Next step is to look at what's happening to the x and the number. What's going on, Sean? What is happening to the x and the 1/4? What's that sign next to it?
No, I'm adding.
The operation is adding, so I'm doing the inverse. What is the inverse of adding? Silent hands. What's the inverse of adding? Nora. So let's subtract. Whatever you subtract to one side, you have to subtract to the other. Remember, I do not really care about the answer at this point. I need you to set up the problem like this. On the left side, the 1/4 is being subtracted by 1/4, so we cross those out. That's the goal, is to get x by itself, so we're happy. The x is isolated. On the right side, what is happening, Mason? What's happening to the 3/4 now? To the right of your problem, show this in a clearer way. Put 3/4 minus 1/4, and the denominators are the same. I can subtract the top. So this x actually equals 2/4. Or you could simplify it to 1/2. Okay, so quick refresher of the steps. That's about as easy as it's going to get today. Chad.
So wouldn't it be easier to do the mixed version because if you do it like that, like if you do 2/4 plus 1/4 equals 3/4, that's easy to see. But if you do 1/2 plus 1/4, then you have to do the whole like adding thing.
Right, and I get what you're saying. So like, why would you change the 1/2? Because 1/2 and 1/4 don't really match. When you solve an equation, you're really looking for just the simplest version of x, and so I'm really looking for that thing. But I get what you're saying for checking it. You could probably just leave the 2/4, and let's put 2/4 back into the equation. So let's check the work really quickly. 2/4 goes in place of x. Where you see x, put 2/4. Then add the 1/4. If you solve this correctly, you should have the same number on the left and the right. Do we get the same number? Yeah, so you know you got the answer right. You can check it off. On a test, that is a simple way to get the right answer. If you check your work, plug it back into x. Example 2. This time you have w plus 10.4 equals negative 13.2. Lauren, what do I do first to solve an equation? We want to separate two sides. Next step, look at the operation. Justice, what's happening to the w? We want to isolate it, but I want to know the operation because I'm looking for the opposite. What operation, add, subtract, multiply, or divide, is happening to it? What is going on with this left side? It's adding. So Raiden, what would I do that's the inverse of adding? Yeah, what number am I subtracting by both sides, Daniel? Subtract to 10.4 and subtract to 10.4. Be very careful of signs. If you did it correctly, the left should cancel. What's left over on the left side? What is the only thing left on the left side, Sierra? Great, and that's what we wanted. On the right side, be careful. There are two negative numbers. What are these numbers doing? Fighting or banding, Mason? Beautiful. Let's write scratch work to the side. If they're banding, you're adding them up. And Mason, do you have the answer? Let's check. Remember, when you add decimals, you always want to build a snowman. So let's add the 13.2, the 10.4, and add the decimal. 2 and 4 is 6, 3 and 0 is 3, 1 and 1 is 2. Question in row 3. I didn't make a blunder today. Daniel, do you have a question? No? Okay. Head to example 3. These all three problems are semi-simple. You'll see when we head to the end of bronze, they get slightly trickier. That's kind of like your silver section. Before I start, first step, Reese, what do I do with an equation? Great. This time, something's kind of funky. What is a little bit different about this problem? Got 4 hands. What is a little different from example 2? Nora, what do you see? The cue's like on the right side. Does that change anything about this problem, Jameson?
No, it doesn't. And also it's different is that there's 2 different denominators.
There's also a 3 and a 2. That's going to come into play later. If you have a cue on the right side, just leave the cue on the right side. You don't have to move it around. It's okay to get an answer that looks like this. That's an okay answer. You could always flip it around. Paige, what is happening to the cue right now? It's being subtracted, and you have the right idea. We want to cancel it. How would I cancel the 1/2? Great. Add 1/2 to both. Draw your line to separate the step. Mara, what is left over on the right side? If I cross out these 1/2s, negative 1/2 and positive 1/2 cancel. What's left over? The cue. Leave the cue to the right side. And 2/3 plus 1/2. Going back to, I think Chad caught it. This is a little different. You can't add those. They have different numbers. 3 and a 2 don't work. Jameson caught it. Cool. So Jameson, what numbers would I change the 3 and the 2 to? Back to unit 2. If we forgot how to do this, just skip count until you get to a common denominator. It is 6, so 2/3 should become 4/6. 1/2 becomes 3/6. And you get 7/6. If you wrote this, that's fine. I think the answers today are going to be a little more simpler than that. Let me check. Yeah. So that's an improper fraction, 7/6. It is positive. Help me get a mixed number. Mason. Cute. Cool. Yeah. Because the cue is on the right side, it still is okay. I'm going to give you 5 points out of 5 points on a test, but you can write it like that. It's the more mathematical version of a number equaling cue. That is your answer. Let's see. Yeah, we're okay. Go to the section that says independent practice. I'm going to give you 4 minutes to check your answer with your partner. I want you to be very precise with your steps. If your partner forgot to add something on both sides, but they have the right answer, I want you to respectfully tell them to be precise and go ahead and add it. 1, 2, and 3 are similar to Friday. They should go pretty quick. Once you hit 4, it is a decimal. Show all your work on the right of your paper. You got 4 minutes. Go. Yeah. Let's move. Lauren's going to stop by for 4 minutes just to check your work. When you check your answer with your partner, you should also go to the answers and check the back. Make sure you have it correct. Don't move on with the wrong answer. Practice doing things well, not doing things